could get your hands on the complete playbook for building sophisticated AI, the kind that can actually think, plan, and act on its own? Well, a Google engineer just laid out the entire strategy, and it reveals the core patterns that separate the pros from, well, everyone else. So let's dive in and break down this playbook.
It all boils down to this one number, 20. According to this guide, there are 20 core agentic design patterns. And really, understanding these is the key to unlocking that next level of AI development. These aren't just abstract theories. We're talking about practical, in-the-trenches solutions to real-world problems you're probably facing right now.
Now, to make sense of all 20 patterns, we're going to group them together. We'll start with the basics, like how to break down huge tasks, then move into making smarter decisions. The important stuff, like quality and safety. Then we'll look at building truly advanced systems. And finally, we'll wrap it all up in a single, easy-to-understand blueprint. So what are these agentic design patterns anyway? Well, think of them like a professional playbook, or maybe even architectural blueprints. They're proven designs for creating AI agents that can operate independently and tackle really complex problems. Okay, our first challenge is one I'm sure you've run into. How do you get an AI to handle a task that's just too big for one command? You can't just tell it, hey, go reduce customer churn by 20% and expect a miracle. You need a strategy, a way to break that problem down into manageable chunks. And the first pattern for this is called prompt chaining. The analogy here is absolutely perfect. Think of an assembly line. Each station on the line, or in this case, each prompt, does one very specific job. It then checks its own work for quality, and only then does it pass the result down to the next station. This whole modular approach is just fantastic for quality control. And you can see that flow right here. The AI gets this huge task, it breaks it into smaller pieces, and then it executes them one by one. But here's the crucial part. See that validation date after each step? If the output of step 1 isn't right, it doesn't even move on to step 2. This is so important because it stops a tiny error early on from completely derailing the entire project. But what if you need speed? I mean, who doesn't, right? That's where the parallelization pattern comes into play. So instead of a linear assembly line, imagine you've got 10 people and you give each of them a different chapter of a book to read at the same time. Then they all combine their summaries at the end. That's the idea here, splitting a job into independent chunks that multiple agents can tackle all at once. Okay, so our agent can break down big tasks. That's great. But now, how does it decide what to do next? When it's staring at a bunch of different options or it needs information from the outside world, it's got to have a way to make a smart choice. This is where the routing pattern comes in, and this analogy from the source just hits the nail on the head. The AI acts like a smart receptionist. It listens to the request, figures out what you really need, and then sends you to the right specialist. Is this a tech support problem, a sales question? The router figures it out and sends it to the right agent for the job. And part of making a smart decision is getting the right information. This slide compares two really key patterns for that. On one hand, you've got tool use, which is all about reaching outside the system, using a web search, an API, maybe a calculator. On the other hand, you have knowledge retrieval, or RAG, which is about looking inside, searching a secure, pre-approved company knowledge base to find answers you can actually trust. All right, let's talk about something that's, well, it's probably the most critical topic here: trust. We can build these incredibly powerful AI systems, but if we can't be sure that their outputs are accurate, safe, and reliable, then all that power is actually pretty dangerous. This next set of patterns is all about building in those essential checks and balances. I mean, this brings up a fundamental question, right? AI is not perfect. We know this. It hallucinates, it makes logical errors, it spits out flawed first drafts. So what's the game plan when that happens? How do we actually catch and correct these mistakes before they cause a real problem? Well, the reflection pattern offers a pretty brilliant solution. Basically, you create a second AI agent, a critic agent, whose only job is quality control. Think of it like a teacher looking over a student's essay. The first agent writes a draft, then the critic agent reviews it against a specific rubric, gives detailed feedback, and sends it back for revisions. And it keeps doing this until the essay gets a passing grade. And reflection is just one piece of the puzzle. The pros build layers of defense. They use guardrails to scan incoming requests for harmful content, kind of like airport security. They build in exception handling, which is basically a plan B for when things inevitably go wrong. And for those really high-stakes decisions, they use the human-in-the-loop pattern, making sure a person always always has the final say. So far, we've covered how to make a single agent smarter and safer. But the real magic, the real power, happens when you start building systems where multiple specialized agents can actually work together as a single coordinated team. This is the multi-agent collaboration pattern, and the film crew analogy here is just perfect. You've got a director, that's your orchestrator agent, and they're coordinating all the specialists, the camera operator, the sound engineer, the lighting expert. They all share the same script and shooting schedule, or in this case, a common memory and goal, to create something that no single one of them could have ever done alone. And to make that film crew work, you need some key infrastructure. You absolutely have to have all these pieces: a manager, your specialists, a shared memory so everyone is literally on the same page, a way for them all to talk to each other, and, this is critical, a way for the entire system to learn from its mistakes and get better over time. All right, we have covered a ton of ground, from simple chains all the way up to these complex collaborative teams. So now, let's just pull back for a second and put all of this into a clear, high-level blueprint that shows how all these different categories fit together. This simple chart really lays it all out. Each group of patterns solves a different fundamental problem. When a task is just too big, you use patterns like prompt chaining. When an agent needs to figure out its next move, you lean on routing or tool use. When the output could be wrong or even unsafe, you absolutely must have reflection and guardrails. And finally, when one agent just isn't going to cut it, you build a whole collaborative system. This right here is the blueprint. And that brings us to the big picture. We now have the architectural plans to build some incredibly capable AI. But as these agents get more and more woven into our daily lives, the real question isn't just about what they can do, it's about whether we can trust them. So I'll leave you with this. Which of these patterns, the decision makers, the safety checkers, the collaborators, which one do you think will be the most critical for building a future we can actually genuinely trust?